Hi, welcome to Catia V5 video tutorial. Today I want to do kinematics, DMU kinematics. It's all about mock-up, or let's say fake. So just to show what I want to achieve, let's start mechanism, simulation. So this turns around there, over there, and this stops, and if it goes back, that one will stop, and back again. And if you want to do something like this, you have to use laws or rules. Okay, so I will show you how to do this example. So let's start with a new and empty product in the assembly workbench. So first I want to insert existing component into this product, and let's take a look. They should be on that. Nope, on the other one. In the documents, and there it is. I need the base, the center gear, and a gear. I bring them in all together at once. So let's move this, okay, and move that a little bit. Okay. You could do it with assembly constraints and exchange them into the joints, or you could do new joints. But at the moment I will fix this in space. So go for where it is, fix this part in space, and maybe give you some different colors. This should be, let's say, like this. This one might be cyan one, and that one might be orange one, and I need a copy of this one, so I will Control C, Control V, and let's see, I position my compass right here and select the new part and move it. So this should have a different color. Let's say it's red as in my preview. Okay, now let's do some constraints. So this axis should be on that one, this one on that one, and this one on that one, and this surface, oops, on that one. Opposite, yes. Usually you should do all constraints one after the other, but it works. Now make an update, and all the parts are in the right position. So let's hide all the constraints. Okay, and move them into position So let's take a look. Where is it? Move. There you go. I want to turn with respect to constraints around that axis, this part, maybe like this, yeah. Then around that axis, this one a little bit, yeah, it's okay. And also the other one a little bit. Yeah. And okay. Now let's go to our DMU Kinematics workbench. You could magically convert these assembly constraints into kinematic constraints, but I will do it manually. Okay, so first I need a new mechanism. Call it mechanism 1, doesn't matter. Okay, and select one fixed part, and this should be the fixed part, and you got a new mechanism. So now I need 3 joints, and I will go for revolute joints. They should do the trick. So let's move them put this right on top like this, select those parts and move them a little bit away, but you should not select all, so this one should not be selected. Only this one, that one, and that one. Okay. Now let's make the joints. First one from that axis to this axis, and this surface to that surface, and the offset should be -1. Okay. Now let's move again that one over here, make another revolute joint, this axis to that axis and that surface to that one. Again, offset should be -1. And another one, axis to axis, face to face, and offset again -1 in this case, because one gear is 1 millimeter width. Okay, let's hide all the constraints. And now I could make all these 3 joints angle driven. Make it angle driven. Okay, next one as well, angle driven, and this one again angle driven. Now I can simulate this because I can control all 3 gears. See? Yeah, you could do it on request. So just move them over here and all 3 will turn in the same direction in this case. Stop and reset. Close this one. But I cannot achieve the situation which you saw in my preview. So I need laws. Therefore, I will go to the KnowledgeWare Advisor workbench, this one. And there I can make rules. So first I want to give all gears one rule, so they turn in one direction, and let's say 2 degrees per second. So let's start with a new rule, call it, I will start with the center gear and call it orange gear. Okay. And I need an angle because this is controlled by the angle. So let's go for angle, and it was my second revolute joint, so it should be command 2 angle, and this should equal the time divided by 1 second to get the units right, because I need degrees, multiplied with 2 degrees. And I will copy this one. Okay. Let's see if it works. Or let's do the other rules beforehand. So I'll call this red gear. Okay. Paste. Make this 1 instead of 2. Okay. And another one, call it cyan gear. Confirm, paste, and call this command 3 instead of 2. Okay. Now let's check if it works. Go back to our DMO Kinematics workbench. Go for simulation with laws. The time should be, I want to have 120 seconds. And the number of steps should be maybe 1000, so it's very easy to see what will happen. And you see all the gears turn in the same direction with the same speed. That's not what I want, but it's a first step. Okay. Okay, next I will make this orange gear move different to the other ones. So let's check it out. That's this one, that's the orange gear. Double click. So what should happen? I want a length of 120 seconds. In the first 30 seconds it should turn clockwise. In the next 60 seconds it should turn counterclockwise, and in the last 30 seconds it should turn again clockwise. So I need some sort of case. First case, if the time, the kin time is, go to operators, less or equal than 30 seconds. Don't miss the seconds. Then it should do the following. It should turn the gear 2 degrees per second. Otherwise, else, if the time, I could copy this, Control C, Control V, is less or equal than 60 seconds, or less than equal than 90 seconds, because the next 60 seconds it should go the other way. The angle should be 120 degrees minus this expression, because this gets bigger and bigger. At 30 seconds this value is 60 degrees. You see? Let's check this out if it works. Just close the brackets. Okay. And of course I forgot. Let's see, degrees, that's okay. There is a bracket. That's okay. Oh yeah, I forgot space right here. Still not. Kin time. Same here because I copied it. Okay. Let's check it out. "30 seconds, then it goes back, nice, and goes to the other side, very nice." Close this one. So go back to the rule editor. Always consider, if this condition is fulfilled, it will not check further. Yeah? It's sort of cascading. So I need another case. Another else right here. Else just paste this expression, copy it and paste it right there. If it's less or equal than 120 seconds, this should be minus 240 degrees plus mechanism times seconds, and I need another bracket to close this one. Else there should be a bracket and there should be a closing one. Okay. Let's check it out. It goes back 90 and it goes back again. Very nice. And close this one. Okay, now let's go to this one. In the first 60 seconds it should turn counterclockwise. In the next 30 seconds it should turn clockwise, and then it shouldn't turn at all. So go to the sine gear and make a new rule. If mechanism kin time is less or equal, go to the operators. You could write it, of course, less or equal than 30 seconds. It should turn the other way around, so it's minus mechanism kin time divided by 1 second multiplied with 2 degrees. Else let's make brackets just for better overview. Okay, if the mechanism kin time, so go for parameters, time, double click, is less or equal 60 seconds, this one, just copy it, Control C, Control V, should be minus 120 degrees plus this one. Let's check. Looks pretty good. Stop it, go back, close this one. Okay, this side works already, the other side. So let's go to the red gear, and maybe I could, I will start from scratch. So if this gear should turn when I think it's 90. Let me check. No. This gear should turn clockwise beginning with 60 seconds, and it should turn counterclockwise beginning with 90 seconds. So I will make it this way. If the time is greater or equals, go go to the operators. It's greater or equals 90 seconds. Then the angle should be, it should turn beginning with 90 seconds. It's right here. The value should be 240 degrees minus this expression, else if mechanism kin time is bigger than 60 seconds. So go for operators, 60 seconds. Then it should do the following. It should, the angle should be parameters, the angle, that's command 1, this one should equal minus 120 degrees plus mechanism kin time divided by 1 second multiplied with 2 degrees. Okay, let's check. Okay, first 30 seconds, second 30 seconds. Yes, looks good. Looks really good. Okay, so I'm done. Hope you enjoyed this one. If you want to see more kinematics, give it a like down below or leave some nice comments. Thanks for watching. See you to the next one. Bye bye.